everyone. This is the second page of the Chapter 6 exam review for Algebra 2A. And this kind of picks up where the last page left off. These next two problems are really similar to the last ones on the previous page. I think I'm actually going to do number 12 first, because I think once you see how to do number 12, number 11 will come to you really quickly. So I want to reiterate, and I mentioned this in the last video if you watched that one, but what this is saying is log base b of 5 to the 4th power, like that power of 4 is attached to the 5. That is not the same thing as log base b of 5 being raised to the 4th power. Okay, those two things are not the same. And the reason I take the time to point that out is I have a lot of people who, on a question like this, they want to take this decimal and say, okay, well, I'm just going to take that decimal and raise to the power of 4. That would be the case if this is what we were trying to do, but we're not. We have to raise the 5 to the power of 4, not the log to the power of 4. So there's only one minor difference here, really, is we just need to get that 4 out of the way so that we're looking at just a log base b of 5. So I'm going to take this exponent down in front, just like we've been doing, and think of this as 4 times log base b of 5. And then I can replace log base b of 5 with that decimal, 0.893. And so I'm really just doing 4 times that decimal. And 3.572 would be your answer there. So now let's go back up to number 11. And number 11, again, the idea here is to take this 1 over 25 and rewrite it using the numbers that were given, using the 5 and the 2. Technically, we can do it with just a 5, okay? And I can think of a couple different ways we could do this, but I think the easiest way is going to be for me to say 1 over 25 is the same thing as 1 over 5 to the power of 2. Okay, so digest that for a second, that 25 is really 5 squared. And then remember that to make an exponent flip over like that, you can really use a negative exponent. So I could think of this as being the same thing as 5 to the power of negative 2. So what I'm really being asked to do here is log base b of 5 to the power of negative 2, and then look at that compared to what we did just a minute ago. It's really the same idea. So I'm just going to say, okay, this is the same as negative 2 times log base b of 5, and then I'm going to take that log base b of 5 out and replace it with 0.893. So I'm doing negative 2 times 0.893. Oops. And I end up with negative 1.786 as an answer. Okay, let's look at number 13 here. And I want to point out a key word here in 13. It says this machine depreciates continuously so that after 3 years it's worth half its original value. But that word continuously means that I'm using the continuous growth formula, which is PE to the power of RT. Okay, continuous growth uses E. So this question, find the annual rate of depreciation, means we're really trying to find what R is. So let's think about what values we have. We don't have an initial value or a final value. I'm going to circle back to those in a minute. So I guess the only thing we know right now is that it's going to be E to the power of R, which is what I'm trying to solve for, and it's going to be after 3 years. And I need a P value here, and I need it equal to something on the other side. What I want to make happen in this 3 years is for it to become worth half of its original value. So we've talked about this before, that you could technically make up an initial value and then just cut it in half for this over here. If you're going to do that, let's make this as easy as possible. Let's say that our initial value is 1, and then our new value is 1/2. Okay, so this is me cutting in half. Now I could do something like, 100 here and 50 here. But then my first step to solving is going to be to divide by this number. And no matter what, this should work out to be 1/2 when you do that. So if you want to just make it easy on yourself, start with this equal to 1/2 over here, and then this is really like a 1, which we don't have to do much math with. So let me just rewrite this here. This would be like 1/2 equals E, because I don't really need the 1, and then I'm going to rewrite this as 3R. Okay, so now what I'm dealing with is a situation where I have a variable in the exponent. We talked about that in the previous video. If you have a variable in the exponent, we bring it down using logarithms. And you could use a regular common log here if you wanted to. What's going to work better for you because of this E here is a natural log. So I'm going to take a natural log on each side. I'm going to move the exponent down in front like I've been doing. So now I have natural log of 1/2 equals 3R times natural log of E. So if you were to go back to what we did on the first page, our next step would be to divide by this log right here. But because the base of a natural log is E, this natural log of E is really just equal to 1. So we can really think of it as just canceling out. And so now I don't have to worry about that natural log E. That's why I said to use a natural log, because I knew that would happen. And so really all I have to do is natural log of 1/2 divided by 3. So I'm going to divide by 3, divide by 3. Natural log is right here, so natural log of 1/2, or 0.5. Oops, and I meant to divide that by 3. So natural log of 1/2 divided by 3 is negative 0.23. So I get that R, which is my depreciation rate, is negative 0.23. It does not shock me that that came out to be negative because we knew that the machine was depreciating, right? So the rate should be negative because it's going down in value. So how long before the machine is worth 30% of its original value? So I'm kind of using this same structure here. I'm still going to think of this initial value as 1, but I want it to drop down to 30%. So what I'm really going to do here is set this equal to 0.3. There's really a 1 here, but I'm not going to write the 1 because we don't really need it. Now this time, I know my R value. I can use this negative 0.23. But the time is what I'm solving for. That's actually not going to make much of a difference mathematically. We're going to solve this the same way. But this time I'm looking for the amount of time, and I know my R value. But once again, I have a variable up in the exponent, so I'm going to solve by taking a log on each side, and I'm choosing that natural log because of the E. Put this down in front. So we have natural log of 0.3 equals negative 0.23t times natural log of E. Again, natural log of E drops out of there, and then really all I'm doing here is dividing by that negative 0.23. I can't decide which pen to pick up, sorry guys. Divide by negative 0.23. So natural log of 0.3 divided by negative 0.23 works out to be 5.23. So that's your number of years. So I would say t equals 5.23 years, which seems reasonable to me, right? Because if it takes 3 years for it to cut in half, it's going to take a little bit longer than that for it to drop down to 30% of its value. Okay, 14. Here we have to remember the different types of compound interest. So for these first two, when I'm compounding quarterly or monthly or daily or, semi-annually, we're using the regular compound interest formula. And let me jot down that formula here. P1 plus R over N to the power of N times T. So if I'm compounding quarterly, I'm gonna write out all of these formulas first, and then we'll crunch the numbers on them. Let's see, my initial investment, so that's P. So that's 500. 1 plus, my interest rate is 10%, so I'm going to do 0.10. And then N is how often we're compounding. So if we're compounding quarterly, that's divided by 4. And then we're going to go to the power of 4 times, and this is after 5 years, so that's my T value. Let me just label these up here real quick in case you need them. So the principal is my 500. My R value comes from that 10%, so that's 0.10. And then my time is 5 years. Okay. Okay, and like I said, I'll crunch the numbers on those in just a second. The only thing that's going to change with monthly is that n value, instead of being 4, is going to be 12, because we're going to do it 12 times a year. And I would expect that to be just slightly larger. And then this last one, continuously, that's, again, there's that trigger word, right? Continuously means I'm using the PERT formula. So here I'm using this. And remember that what that E is really doing is making it so you're compounding like almost constantly. And that E to the power of R really replaces this whole middle parenthesis piece. And you don't necessarily need to know that that's where it comes from, but we did talk about that in class. So my P is still 500. And then I'm doing E to the power of that interest rate, which is 0.1, times my time, which is 5. Okay, so now let me go ahead and type these in, and they should pretty much go in exactly the way they're written. So 500 times 1 plus 0.1 divided by 4 to the power of, now on this kind of calculator, I'm going to need parentheses around that exponent. On most of the newer calculators, you wouldn't. And so that's $819. Gosh, that grew quite a bit, but I mean, 10% interest is pretty high, so I guess that seems reasonable. So this is 819.31. For this next one, the only thing that changed is I did a 12 instead of a 4. Okay. And so that gives me 822. Remember I said that would give you just slightly more. And then continuous interest, I would expect to be just slightly larger than that. So for this one, I'm doing 500. The E is up above the ln key, so you could hit second ln, and that gives you E to the power of, and then you can just type in your exponent, which was 0.1 times 5. And that gives you 824.36. Okay. So let's see. Money being invested in an account paying 8%, compounding continuously. How long will it take the money to double and to triple? Okay, so once again, I see that word continuously in here, which means I'm using PERT, right? And I'm going to kind of use the same idea that I used in number 13 here, that if I want my money to double or to triple, I could pick a number for P and then double it and make that A. And then I'm going to end up solving for T up here. But my first step would be to divide by whatever's here for P. No matter what you choose, if you made it so that it would double, when you do that division, you're going to end up with a 2 over here. Okay, and then no number left over here because you would have divided it out. So I'm just going to start with that. I'm going to start with a 2 over here for A because I'm doubling. And then I'm going to go E to the power of 8% means I'm doing 0.08 times T. When I want to triple, let me just set up both these equations. I'm going to set this equal to 3. So again, if you don't think to do that, if you don't think to do that with the 2 and the 3, you can just make up a number for P and then triple it or double it or whatever you need to do for A. And then the very first step you'll take will be to divide by whatever that P value is. This is where you'll end up when you do that. So I'm just kind of saving you a step, but if you don't remember that, you can just make a value up. We have variables in the exponents, so hopefully by now this is sinking in that we need to take a log on each side, right? And because it's involving E, it's going to be easiest if we do natural logs. And I'm just going to kind of work through these side by side. So this is going to move down. Whoops, didn't mean to move all the way over there. This is going to move down in front of this natural log. This is going to move down in front of this natural log. So here we end up with natural log of 2 equals 0.08t times natural log of E. Here we're going to end up with natural log of 3 equals 0.08t times natural log of E. In both of these cases, remember that natural log of E technically cancels out. It's equal to 1. That's why we can say that it cancels out. And so really all I'm doing now is dividing by 0.08. Don't know why I started way over there, but divide by 0.08, divide by 0.08. So I'm doing natural log 2 divided by 0.08. So there's this one. T equals, so it's going to take 8.66 years for the money to double. For the second one, I'm doing almost exactly the same thing except natural log of 3 instead of natural log of 2. And we end up with T equals 13.73 years. And there we go. All right, let's see, we're already up to 15 minutes here, so I will go ahead and start another video for the next page of this packet.